welcome back to our channel Euclid Mathematics. We have started lecture series on CSIR NET SET Gate and other competitive exam. Within that, I'm explaining here some of the previous year question from CSIR NET. Okay, so here in my today's question, I'm going to explain to you all one of the important question from CSIR NET exam, which is completely based on nullity, rank, and all these concepts. Okay, now let's get started with today's question. I'm going to explain to you all first of all question, then we'll move for detailed understanding of solution. So here in our question we have given question, it is from paper third, that means 4.75 marks question. That means our option one or more than one option is true. Okay, sometimes none of it is true also, so we have to be very careful about this. So question, it is given A, B an invertible matrix. Okay, so we all know that now, invertible matrix. So already I explained it into my previous lecture, the invertible matrix properties and all the stuff related to our today's question. So if you wanted to see this video, you may check it into my playlist. So here we have A is the invertible matrix, which is a 4x4 real matrix is here. Then which one of the following are not true? So here be careful about not true. Not true means they didn't given here, that is a false. Okay, not true. So sometimes it is coming like which of the option is a false or which of the option is a true, but sometimes which is a not a true. So we have to check which is a not true. First of all, we have to find out which is a true and then make it opposite corrections here. Okay, so here first option, rank of A is a 4. For every vector B belongs to R raised to 4, x which is equal to B. Okay, x which is equal to B, which represent non-homogeneous equation of matrix. Okay, x which is equal to B has a exact one solution. Okay, and option C, dimension of a null space which is greater equal to 1. 0 is eigenvalue of A. Okay, so we have to check whether which option is correct and then check out for not true. Okay, so we have to find out the true option first and then select only not true here. Okay, so we have to go for exact opposite direction. Okay, now let's get started on today's solution. We are going to detail understanding of our today's solution. Here in our solution we can see here A is the invertible matrix. Okay, so A is invertible matrix like a non-singular matrix. Always remember, invertible matrix means determinant of A which is a non-zero. Okay, determinant of A which is a non-zero. Okay, that means 4x4 real matrix is this one, invertible 4x4 real matrix. We have to check whether rank of A is a 4 or not. Okay, so rank means the matrix which is having at least one non-zero element in each row or each column. Okay, so that we call it as the rank. Given a matrix has a rank 1, 2 or 3. Okay, so that means we want the rank of a matrix is the 4. so if it is 4x4 matrix, it is invertible, that means determinant non-zero. Then whether it is a rank 4 or not means at least one element in our row we need a non-zero. Then we say that rank of A is a 4. Okay, so we have to check there exists the element. Okay, there exists element in each row when, and we have, it is an invertible matrix for 4x4 entries. Okay, so 4x4 entries means it is having 4 rows and 4 columns, and rank of A4 means all 4 rows and 4 columns at least we have there. It's a non-zero entry, that cannot be a 0, that's why it is a rank 4. So if it is a determinant non-zero, that means there exist all eigenvalue which need to be a non-zero. And if it is happening, then we say that the nullity of our matrix which is a 0. And if the nullity of our matrix which is a 0, then we say that our matrix is a full rank matrix. If a nullity is 0, then we say that our matrix is a full rank matrix. And if matrix is a full rank matrix, that means a matrix we have 4x4 matrix, and full rank matrix means 4 rows and 4 columns are there. That means a rank of A we need a 4. Okay, here then only it is possible our matrix is a full rank matrix. So as we know that rank of A which is a 4 option is correct, but we want which is a not true. That means our option 4, which is option number first, eliminated, because this option is correct and which we want not correct. So our option first is eliminated here. Okay, now second check, for every vector b belongs to r raised to 4, x which is equal to b. So x which is equal to 0 and ax which is equal to b. You need to understand the difference between this. Okay, so x which is equal to 0, this is a equation of a matrix, which is a homogeneous form of equation of matrix. And x which is equal to b, this one is a non-homogeneous form of equation of a matrix. Okay, so we have non-homogeneous equation of a matrix has exactly one solution. So we have to check whether it is having exactly one solution or more than one solution or infinitely many solution or do not have solution. Okay, but we have only one condition, which is a determinant non-zero. And if determinant of a matrix is a non-zero, that means the matrix is not linearly, not ELI. Okay, that means it is not ELD. Okay, that means the matrix is not linearly dependent. Determinant of non-zero means matrix not linearly dependent. That means matrix is a linearly independent. So we got the matrix which is a linearly independent. And if the matrix is a linearly independent, then we say that our matrix which is having unique solution. So which is having unique solution. Always remember, if a matrix which is a linearly independent, then matrix always having unique solution. If matrix which is having unique solution, then we say that our non-homogeneous system x which is equal to b, okay, here b non-zero matrix has exactly one unique solution in r raised to 4. Okay, so option number b which is correct, but we want the not true, so option number b which is eliminated here. Okay, now let's go for the third and fourth option. C, dimension of a null space which is greater equal 1. Okay, so we have dimension of a null space which greater equal 1. Okay, so what is mean by dimension of a null space? Dimension of a null space always represented by nullity, which is the opposite of a rank. Okay, so dimension of a null space means we have to work here for nullity. Okay, and here we found nullity in our linear algebra. We studied nullity in a Sylvester law. Okay, and what is the Sylvester law? It says that dimension which is equal to rank plus nullity. Okay, so dimension of a null space can be written as dimension of a rank space plus dimension of a null space. Okay, so dimension of a nullity we have to find here. That means null space means nullity. We want the nullity here. We have to find out a nullity. Okay, so dimension can be written as rank plus nullity. Nullity, which is the Sylvester law, very famous law in a linear algebra, which we always use to find out dimension, rank, and nullity. Sylvester law. Okay, very important law. Always need to remember dimension is equal to rank plus nullity. Okay, so what is the dimension here in our matrix? Okay, if matrix is a n by n we have here, then we say that n is the dimension of a matrix. Okay, that means the rows and column which present in our matrix, then we call it we say that it is the dimension of matrix. Okay, so here matrix is a 4 by 4, that means a dimension n which is equal to, I got the 4. Okay, so dimension is a 4. Rank, I found it here in our option first. Rank of A is a 4, that means the invertible matrix, full rank matrix. So rank we have here 4, which is plus nullity. Okay, so here we can see nullity 4, take it here, so 0, I got the nullity 0. I got the nullity which is a 0. If a nullity is a 0 here, then we can say in our option dimension of a null space means nullity which is given 1 or bigger than 1. 1 or bigger than 1, but 0 does not belongs here, does not belongs 0. 0 is not contained here. So if it is 0 not there, then our option number C, which is a wrong. Okay, dimension of a null space is a 0, but it is given 1 or bigger than 1. So this option is a wrong, but we want not true. We want not true here. So this option is correct as per the condition. Not true means this option is correct. Okay, now 0 is an eigenvalue of A. Okay, can it possible 0 is eigenvalue of A? Now let me explain two results to you all here. Okay, so when we want eigenvalue or when we want trace of a matrix using eigenvalue, okay, so we use two results that we commonly use for finding eigenvalue or determinant of matrix. Okay, which is a trace of a matrix which is equal to addition of eigenvalue and a determinant of a matrix which is a multiplication of eigenvalue. Okay, so determinant of a matrix means we have determinant of a, consider A. Determinant of matrix we write as the multiplication of a eigenvalue. So lambda 1 multiplied by lambda 2 multiplied by lambda 3 multiplied by lambda 4. Okay, so these are the 4 eigenvalue. Because matrix is 4 by 4, surely we'll get the 4 eigenvalue. If a determinant is a non-zero, so surely we can see that lambda 1 need to be a non-zero. Similarly, lambda 2 need to be a non-zero. Similarly, lambda 3 and lambda 4 all need to be a non-zero over here. Okay, if lambda 1 non-zero, lambda 2, lambda 3, lambda 4 all eigenvalues are non-zero, surely we will say that their multiplication it is also non-zero, and we know that determinant of A is a non-zero. So this condition hold as we have given in our question. So it is given 0 is eigenvalue of A, but not possible lambda 1 non-zero, lambda 2, lambda 3, lambda 4 all these eigenvalue 0 not possible. Okay, but it is given 0 is one of the eigenvalue of A. So as we have here, this option is a wrong. Okay, this option is a wrong, but as per our question not true. As per our question not true means our option D, which is a correct. Okay, so option C is correct, option D is correct. Okay, now let us see the detailed solution of our question. For your detailed understanding, you may refer this step of the solution that I written little shortly here, that I explained everything in detail in my previous part. Okay, so you may check everything there. So here we can see all the complete solution of our options. Okay, so I hope you all have understood my today's lecture. It is completely based on nullity, rank, Sylvester law, this all topic from linear algebra. I hope you all have understood everything. Even after, if you do have any doubt, difficulty, let me know in comment section. I will come up with a different video. So thank you everyone. Thank you for my today's lecture.